I'm not sure that I'm the one who keeps the lights on, but I'm at least the one who gets to talk about how we kept the lights on over the past year. Thanks, Sid. I'm wearing the shirt for 5th Racket Con. So it's impressive being here at 14th Racket Con. Does the list library actually provide the 14th function? I feel like I should add a pull request every year to add more accessors for each of these. But it is impressive to be here at 14th Racket Con. I've been to all of them. I think I'm the only person, and you've been to all of them, Jeff? Oh, congratulations, Jeff. I'm glad that we've been there together. I started this in 2011, and it's been a fun time. Hopefully we get to add the 28th function to, should there be a hyphen in 28th when we add it to the list library? I think so. Okay, well, the State of Racket. How is the State of Racket? Oh wait, how'd that get there? The State of Racket is strong. So I think we are very fortunate to be where we are as a community. We have lots of people here who are excited about Racket. Many people who have been to almost as many Racket Cons as Jeff, and many people for whom this is their first Racket Con. How many people are here for the first time at Racket Con? We look forward to having you here for 14 more. But the State of Racket is great. We're doing really well. That credit is to all of you out there who have done the work that I get to tell everyone about in this talk every year. So this is one of the things that I enjoy about giving this talk, is that this is the most boring and predictable part of these slides, is that every year I just go through and I change the numbers on this slide, because every year we release 4 times a year on schedule, and this happens consistently. It works. People can download the releases. I remember a time in the Racket community when it was not like that. And so this is an impressive achievement for us as a community. Coming soon, 8:15, I just saw the pull request, or the commit that John did to start off the process for 8:15. And the credit for all of these great releases really goes to John Clements, our intrepid release manager, whose foot this is. So if you've ever seen the stepper icon in Dr. Racket, it is modeled on this picture of John's foot. This is 100% a true story. Who took this picture of your foot?
You can see my head in it, so
It's probably not you.
If it was, you're very flexible.
Okay. So over the past year, we've done a bunch of new, exciting improvements to Racket. I'm going to talk about some of them, mostly focused on things in the core of Racket and in the main distribution. But one of the important things about Racket is the community, and there's now more than 2,000 different packages on the package server. So the vast majority of work that goes on in the Racket community is not the work that I'm talking about today, but it's important to talk about what we're doing in the core so that everyone sees where we're going and the progress we've made. So one really exciting and important change that we've worked on is support for taking big applications written with lots of modules, where when you open the module browser, you have to scroll way, way, way to the right to get all the way to the end. And compiling that down to something much smaller. So anyone who's looked at the implementation of Hashline Racket Base knows that there's dozens of modules and tens of thousands of lines of source code that are loaded for this very simple Racket program. But the Demodularizer, which is a program and tool that's been incrementally worked on over many years, but has taken some major strides forward for the past year, you can run it and you can throw away everything from this program that's not needed to print out Hello World the way this program does. And when you do that, you get this code, and only this code. This is the whole thing. And you can see it depends on some built-in runtime modules, and it calls current print on Hello World, and that's it. And so this is the whole thing, and you can compile this to a ZO file, and it will be much smaller than what you would get if you packaged up all of the ZO files, all of the compiled code for everything that lies behind Racket Base. Yeah?
What are those dots on the first line?
So that's the language position for the module, and like fully expanded and compiled modules don't have a language. So
This is really
the printout involves 3 dots because that's what Matthew chose to print there. But there's 4 dots. But there's really nothing else. There's nothing being hidden behind those 4 dots. Yeah, so this is fully expanded Racket code and can be compiled directly to machine code with Shea scheme, and this is the whole thing. So this is, if you compiled this and combined all the ZO files that this depends on, you'd get several megabytes of code. And so this is just a few kilobytes when compiled. So you can also now use this demodularization technology in a library. So you can use Hashline compiler demod in your program, and this will produce a new module that's like hello.racket, but with everything flattened out. And this cooperates with all the rest of Racket's tooling. So you can use demodularization in your package that's on the package server. You can use it in your library that's used in multiple places, and you'll get the flattening and compilation benefits, and also the 4x compile time increase that's involved in demodularization.
I don't understand when I would use this in something that's not a main, but if that's too much, don't.
So you would use this if you have a large library that's built out of many modules, but no one else needs to know about the internal modular structure of your library because you're just exporting one thing, and the loading cost or the I/O cost of working with all of those modules is significant, and you want to save that. So one place where this could potentially work, for example, is Match. Match is implemented with a dozen files, but nobody needs to know the internal structure of that code, and so you could flatten it all out and just have one file that implements that from the perspective of the compiler when seeing some person who's using match. And then, of course, as systems get larger and larger, then that makes a bigger and bigger difference. OK, so that's demodularization. And it can make a significant difference in the performance, especially the startup time performance of programs that use a lot of modules. The second piece focused on avoiding runtime cost by moving it to compile time is static FFI call generation. So this is a new feature where you can specify that you want the FFI code to be generated at compile time rather than at runtime. And again, that saves some runtime cost and potentially means that you don't need to have any of the runtime FFI mechanisms available when running your application. Another fun feature is when you run Raco setup now, in the past you used to just get a lot of scrolling output. But now you get a little scrolling output, and then you get this cool progress bar. I had to learn how to use the slideshow animation features so that I could make this progress bar go. Yeah. Unfortunately, you can't just take terminal output and paste it into slideshow and have that turn into an animation. But that would maybe next year. So this is a really neat new feature that you can imagine adding. We can bring to more Racket command line tools and make them nicer to use in the fashion that Robbie built here. So another big important feature that's been added to the core of Racket is Treelists. So just to demonstrate why you might be interested in Treelists, here's a list reverse function that if you were a beginning Racket programmer, you might think this was a good way to implement the list reverse function. Unfortunately, you would be wrong. So this program has some unfortunate performance consequences. When I was making these slides, I originally had 5 lines here, but that doesn't work. So the time it takes to reverse 5,000 elements is not that long, but 50,000 is quite a while, and more than that is totally untenable. However, Treelists are a new list-like data structure that supports many more kinds of efficient operations. With cons lists, getting the first or getting the rest are efficient operations. Doing other things are not such efficient operations. In particular, appending to the end of a list. With Treelists, you get many operations, and they're all efficient. Indexing into the middle of a list, appending to the end of the list, adding to the beginning of a list. You name it, the operation is probably more efficient unless all you're doing is cons, car, and cdr. So when we run these, we get some happier numbers. And Treelists are not, it's not just appending, it's also indexing, it's also adding, pushing single elements to the end. Many other operations are highly efficient for Treelists.
Where's line 5?
Where's line 5? I didn't put line 5 in because then it wouldn't match with the other. But it takes about 400 milliseconds with 10 times as many elements. So, yeah, so with 500,000 elements, it takes about 400 milliseconds on my laptop. So yeah, so still a big improvement over infinity milliseconds.
Any downside to Treelists?
Yeah, so the append function is much longer to spell. And I have to write Treelist to construct the empty list, and I have to require Racket/Treelist. It's not just all built in right there. So all of those are big drawbacks. The other drawback is that, like any more complicated data structure, the things that are the most efficient with singly linked lists are not quite as efficient. So consing on a single element is really fast in Racket for a cons. Constructing a cons pair is just about the fastest allocation you can do. Adding a single element to the front of a tree list is going to be more expensive. Similarly, getting that first element or and more significantly, getting the rest of a tree list, those are more expensive operations. And so much so that there's going to be some applications where you want, rather than iterating through a tree list by getting the rest, you might iterate through it by indexing. And so there's going to be a question about which one of those is better, whereas you would never write a list manipulating program with list ref and a counter. That's a quick way to have your program be very slow. Yeah, Sophia?
Yes, I was just wondering if there were tools or functions to convert between tree list and normal cons list or singly linked list.
So I guess there's two questions. One is there a function that takes a cons list and produces a tree list? Yes. I mean, you can apply the tree list function to your cons list, and that gives you a tree list. There's other more efficient implementations of that, and similarly going the other way. A different question is if you have a program that uses cons lists and you want this program instead, what should you do? Well, maybe you should just convert your whole program to Rhombus, where tree lists are the native list data type. But so far, when I ask LLM Lang to do that for me, it doesn't give me very helpful results. So we're still working on that aspect.
Write some refactoring rules.
Yeah. Yes. So that is actually an excellent suggestion, which is that you could write refactoring rules using resyntax. Resyntax has a new feature where you can write your own refactoring rules and apply them to your own program. So you could write your own refactoring rules to get rid of the cons lists in your program and replace them with tree lists. So this is, tree lists are really designed to be a general purpose data structure and to be useful in almost every situation in which you need a linear indexed data structure. If you need, where you might use a vector or a list currently in Racket. And of course, there's going to be situations where you know for particular reasons that you'll get better performance with some other data structure. But in many cases, the idea is that if you default to using tree lists, you will get good performance from almost all your code almost all the time. So that's tree lists, and there's an extensive API, including mutable tree lists, and so on and so forth. So there's more exciting features. Soroi developed a new and not horribly broken form of pattern matching for hash tables, which is a big improvement. It doesn't do the wrong thing in lots of cases, which cannot be said for the old code. And another fun data structure feature is there's now significant, there's some new highly efficient support for working in functional ways with vectors. And this is partly used to implement the Treelists library, but it can be used for any use that you have for vectors that you need to update and modify in some sort of functional way. And it comes with new, newly implemented primitives like vector extend and vector set. Okay. So one other thing that I wanted to point out is we had the third most PRs, pull requests, merged across the Racket organization over the last year of going back since Racket started using GitHub. There's more years that I don't have on the slide, but they don't fit, but they're not nearly as close, and only really outdone by the pandemic years where, for some reason, people were spending more time contributing to open source software projects. And I checked, these are not all automated PRs created by resyntax. Some are, yes. Look for resyntax pull requests coming to a repository near you. Okay, but I was happy to see this increase, and this is particularly driven by increases across lots of new projects, new parts of the Racket ecosystem, not just contributions to the core Racket repository. Next thing I want to talk about is one of our biggest projects in the Racket community, which is Rhombus. Matthew gave an update about Rhombus last year at RacketCon, and I wanted to continue that update. So Rhombus is an exciting project. One important thing to note about Rhombus is that it still looks much the same as it did when Matthew presented it a year ago, and that's kind of the idea of the progress that's been made in the last year. So one big important thing is that there's long been a question about what will the long-term name of the Rhombus project be? And there was a long, extensive discussion, and we settled on a permanent name for this project, and that permanent name is Rhombus. Yes. Yeah. So I had to keep you all in suspense for something. So more significantly, as this is part of Rhombus's progression through some stages we set out when we began the project a number of years ago. And the current stage is about integration, and that's building libraries, integrating with tools, gaining experience with Rhombus. That doesn't mean that nothing's going to change, but it means that we feel like we've learned as much as we can without writing a bunch of software. And now whereby we, I mostly mean the people contributing to Rhombus who are not me, since I haven't been doing this, have been writing software ranging from regular expression libraries to GUI systems to slide presentation software to documentation, and all of those pieces are informing the continued development of Rhombus. So, for example, there's now Picts, a Pict library in Rhombus that produces code like this. There's a Scribble library. How did this happen to my slides? A Scribble library where you can document your Rhombus code like this. And you can see this looks similar to Scribble today. You have ats, you have curly braces, and you have plain text, but the function calls are written with parentheses after the function name and that sort of thing. So that's a bunch of announcements about the software that we've built. But one of the other responsibilities that I get to have to talk about is managing the community infrastructure that's behind Racket. And we've, over the past year, been involved in an important change in that community infrastructure, which is that we have created a new entity, perhaps, the Racket Foundation, which is going to be the new legal home for Racket's financial, legal, organizational infrastructure. Like everything else that I talk about in this talk, I didn't actually do any of the work here, but many of us in the Racket leadership have been working behind the scenes to create this with the advice and encouragement of the Software Freedom Conservancy, which has been the fiscal sponsor for the Racket project for the last some 6 or so years. We've decided that in conjunction with them that it would be in the best interests of the Racket project to have our own specific to Racket nonprofit entity. And this is a new, it already exists. It has received approval from the IRS as a non-official tax-exempt nonprofit organization. It's going to manage Racket's financial assets, and the existing financial assets we have will be transferred there. And it'll be the legal entity that does things like agree to the software signature that goes with the Racket software that you download from the releases page and that sort of thing. So what this is not is a change in how anyone will experience the Racket community or Racket as a piece of software. We're all still the same people. We're all still doing the same things. We're all still going to host the same conferences and manage them in the same way, but we just have our own specific to Racket legal entity and financial entity that will enable us to do all of the things that we've been doing. Okay?
Where do we send money?
For the moment, you can send money in all the same ways that you have. If, as we transition the current finances and things to the Racket Foundation, we will be happy to send you a personal invitation to send money directly to the Racket Foundation bank account. Or if you've got a 20. This is a new step that we think is going to benefit the Racket community going forward, but is not going to change the way in which we all work together to build the things that are really important to us, which is the software that we build together and the community that we build together.
So I happen to know that Racket is a programming language, but if I was to show this slide to somebody at the IRS, Racket Foundation.
So I can't speak to the blandishments that Matthew provided to the IRS to persuade them that we were not racketeering influenced or a corrupt organization. But it probably is good that we didn't make the RICO joke back in 2010 when we were created the RICO tool. Well, that is, like I said, I didn't do really any of the work I got to talk about. But the thing that's great about this talk is I get to give credit to the people who do all of the fantastic work in the Racket community. And now I want to particularly give credit to all the people who worked so hard to put together this awesome event. Zach and Sorowi did a ton of work to make this happen here on the UW campus, which is a great place to have a programming language event. And there's a bunch of new people from the Seattle area who we're happy to have brought into the community for this. Jesse and Stephen, who are not here, Matthew and Robbie, who are here, did a ton of work in front of and behind the scenes to make this happen. And then, of course, our excellent MC and organizer, Sid. And everyone's done such a ton of work. I see how much work they put in behind the scenes to make this the great conference that it is every year. I started RacketCon back in the first RacketCon, and it's been really a pleasure to get to come to all 14 of them. It's even more of a pleasure now that I don't have to do any of the organizing work. And so I just want to take a moment and thank, on behalf of the Racket community and myself, all of the people who made this event happen. So thank you. And then, of course, thanks to all of you here in the room, here on the live stream, watching in the future. Thank you for making Racket the fantastic community that it is, that I'm so excited to get to be a part of every year and every day that I get to be a Racketeer. So thank you.